We are now recording. Let's go ahead and let's chat with Sean. Sean, can you tell me the answer to any of these? It could be M, it could be ln, it could be x, it could be y. Can you give me any of those answers, Sean?
Not really sure.
Okay.
I need a bit more to solve one.
That's okay. Okay, I thought someone typed me a message, but I guess not.
It was Ian. Ian raised his hand.
Oh, Ian. Sorry, buddy. Ian, you got an answer? Oh, no, I think that's Ishmael. Ishmael, you got an answer, buddy?
I think I do.
Okay, which one do you want to give me an answer to?
Number one.
Number one? Okay. What's M?
I said M is 7.
I agree with you completely. Oops, that's a 7, not a 2 there. That's a 7. Good. M is 7. And do you happen to know what ln is? The length of ln. That's this segment right here.
I don't think so.
Okay. So Ishmael, if M is 7, that means that this is 7 right here. What's 7 plus 7?
Oh, 14, because 7 times 2
This
would be
is 14 then. And then what this is over here?
14, because
It's
7
also
times
14. So what's ln?
14. Oh, no. LN would be 28.
Correct. Thank you very much, Ishmael. That's exactly right. That's exactly right. Good. Okay. Yes.
Is there a way I can make your screen bigger?
Nope. I got it pretty.
You can pin his camera.
Yeah.
All right.
If you hover over it, and there'll be a little pin.
Let's see here. I got the whole screen. I think that's pretty good.
I think he's got like the layout. He's trying to make it on his computer, make it bigger.
Oh, yeah. You need to pin me. Gotcha. I see what you're saying. I'm sorry.
I got it now. Thank you.
Okay. All right. Thank you. Sorry. That was a silly response there. Okay. Anybody got number 2? Let's check with, Grant. Do you happen to know anything how to get number 2, either X or Y?
For X, I got 2.
Okay. So X is equal to 2. So do you mind if I ask you a question? How did you get that, Grant? So if X is 2, well, let's just talk about it here. Let me get a different color. If X is 2, then this distance right here has to be 2 plus 4. So this is 6. And then this distance down here, if X is 2, that's going to be 8 minus 2, which I think is also 6. Does that make sense? Marvin, what do you think? Does that make sense?
Yeah.
Huh? You said yes?
Yes.
Marvin, do you think that makes sense that this segment down here is 6 and then this segment right here is also 6? Does that make sense to you, Marvin? Okay, good. He said no. I agree. This is definitely no. Look, guys, this side here looks longer than this one, doesn't it? Okay, can anyone help me out here in figuring out what X is or what equation we need to write to figure out what X is? Guys, there we go. So Marvin got 4. Okay, so Marvin, okay, so let's check that. So if this is 4, so if X is 4, this isn't going to be correct. If X is 4, then this is going to be 8. If X is 4, that's going to be 4 times 4, which is 16, minus 2, which I think is 14. Does that look good?
Yes.
Yeah.
Yeah, actually, that's also not quite correct. So here's, so let's go ahead and talk about this one. So we've got a little bit of an issue here with what we did last week. Remember this thing right here, let me use, let's use green. This segment right here is called a mid-segment. And there's 2 things about a mid-segment when we're talking about a triangle. Remember, a mid-segment joins the midpoints of two sides. First of all, we know that this side has to be parallel to this side. The other thing is that this length right here has to be half of this length right here. In other words, 1/2 of 4x minus 2 has to equal x plus 4. I'll say that again. This length here has to be half of this length here. So that means 1/2 times this length here has to be equal to x plus 4. So now we can go ahead and simplify this. This would be 2x minus 1 equals x plus 4. Then I could minus x over to this side and then plus 1 over to that side. So it turns out that x is equal to 5. X is equal to 5. And we can check that. If we plug 5 into here, that's going to make this length here 9. If I plug 5 into here, 5 times 4 is 20. 20 minus 2 is 18. And you can see now that this side is half of that side. So the correct answer for this one is 5. All right, I'm going to go ahead and finish this up because we're getting a little bit long on this example. These two guys have to be congruent, so you need to write the equation 4y equals 6 times y minus 1. So 4y is equal to 6y minus 6. So I'm going to minus 6y over here, so negative 2y is equal to negative 6, and y is equal to 3. Y is equal to 3. Okay, any questions here before I move on? Now remember, this was review from last week. This was last week. This is section 5.1 and section 5.2. This is 5.1 and this is 5.2. Okay? All right, let's go ahead and move on to today's stuff. All right. So this week we are going to finish things up and we're going to look at two sections. We're going to look at section 5.4. Oh, do you guys remember last week when I was doing, oh, Thomas, you joined us as well. Okay, I'll get you in there. So section 5.4 is on triangle centers. So we have something called a circumcenter. And this is the point where all three perpendicular bisectors of a triangle meet. It's called the circumcenter. Where the three angle bisectors meet, this is called the incenter. Where the three medians meet, this is called the centroid. And finally, where the three altitudes meet, this is called the orthocenter. Now, guys, I'm just giving you this. I'm telling you, I'm not going to ask you on a test or the final exam for that matter what these words are. I just want you to know that they have special names. Now, it turns out that you study them if you get into more advanced more advanced geometry, but we're not going to worry a whole lot about those today. We are going to worry about this one, though. We're going to talk about this one here, which is the centroid. So this point here, in fact, I might want to add, oh, and let me make sure I mention this. If you want this PowerPoint, just send me an email. I will be glad to send you this PowerPoint. I've already did a video and posted it on Canvas for you to watch. I hope you've already watched it. This is separate from that. So here's our first theorem today. Here's our first theorem. And this theorem says that the medians of the triangle are congruent at a point. Concurrent just means that they hit at one point. And this point is called the centroid. Now, here's the thing that you got to get. It says that the point is 2/3 the distance from each vertex to the midpoint of the opposite side. So let me explain a little bit of what that means. So this right here, this length right here, this is what we call a median. This is called a median. In this case, we have all three medians drawn. And this point C right here, which is called the centroid, it's telling you that this distance right here, just this piece right here, is 2/3 of the entire length. In this case, that would be DJ. In other words, DC is 2/3 of DJ. Now I'm going to erase all the markings I have over here because I want you to be able to see that clearly. Now I'm telling you right now that this is not intuitive. This isn't something that you're going to look at and you'll be like, oh yeah, that's 2/3. No one would think that, I don't think. Okay? So this is something that you're going to have to practice, and you're going to have to deal with these fractions. Oh, and I might even add that EC is going to, and by the way, EC is this segment right here. This segment's length is 2/3 of EG. In fact, let's play a game here. Let's play a little bit of a game. Let's do it in red. Let's say that I told you that this entire length right here, so I'm going to tell you that GE is, let's keep it really simple. Let's say it's 30. If EG is 30 units long, this length right here, if that's 30 units, if that's 30 units long, my question is, what is the length of EC? Let me know when you have an answer. I'll give you a hint. The formula is right here that you need to use. If this length is 30, what's this length right here of EC? The formula is right here. Let me know when you have an answer. And I'm going to update the attendance here real quick because I had a couple of people join here late.
Mr. Alan Liliana showed up too.
Okay. I will mark her as present as well. Liliana, did you want to start that test? Okay.
Wait, we had a test?
No. She's making up a test.
Oh.
Okay.
That's pretty funny.
No, that's a good question. Okay. Liliana, I'm gonna send you the password in the chat, okay? And you can start. You're doing chapter 3, I think, right?
Yes.
Okay. All right, there you go. All right. Did anybody get an answer for this EC segment?
Come on, somebody out there knows it.
Wait, what was the question? That's like 10, isn't it?
Close. That's this side's 10. This is 10. That's right. I need to know this side over here.
15.
Nope.
It's 20.
It's 20. That's the correct answer.
I'm talking about Nolan.
20 is the correct answer. Okay.
How do you get 20? I'm confused.
So, Ishmael, guess what 2/3 times 30 is?
I don't know.
So this is the part where math gets kind of hard for students, is that they're not good at fractions. So I would encourage you, feel free, just use a calculator if you're not sure how to do that in your head, or if you don't know how to work that out. Just take 2/3 times 30 with your calculator and see what the answer is. Liliana, I need you to have your camera on, please, while you're taking the test. Ishmael, did you get 2/3 or 20 now?
Yeah, I got it.
Okay.
Guys, I think that's what Mr. Allen's saying when this is like not intuitive. Like I think Ishmael, you said 15 because you thought it just looked like about half. Make sure we're using those formulas.
Yeah, that's
All right. So now we're going to look at an example, okay? Now I'm just telling you right now, this is a pretty tough example. I'm going to mark this out because we actually don't need this here, because the only thing I'm asking for in this problem is to find X and to find BF. And I'm telling you right now, the reason that this question is hard, I'm going to do it actually in 2 different ways, is because you can't do this. I can't do this with mental math, okay? So here we go. So we are trying to find the value of X, which is basically these 2 expressions here, and then we need to find the length of BF. So this right here, I'm going to go ahead and tell you, this is what we call, these are all the medians. So this point H is the centroid. Now, guys, you don't have to know that. I'm just telling you that's the point of concurrency of all the medians. So that's the centroid. So what we need to know is this. We're going to go back to the following theorem, and it tells us that the length from the vertex to the centroid is 2/3 the total length of the median. So I'm going to say that again. In fact, let me write that. BH is 2/3 the length of BF. This is a fact. This is based on theorem. I think it was 8 point, let me make sure I say that, or not 8, 5.8. 5.8. That's what we need to use. So I've got to use that. In other words, BH is 2/3 of BF. That's a fact. So do we know what BH is? Yes, BH is 3x plus 6. Do we know what BF is? So here's where we're going to have to use something called segment addition postulate all the way back from chapter number 1. So the entire length is going to be this plus this. So it's going to be 3x plus 6 plus 2x minus 1. Now we just got to solve this equation. So this is where the whole algebra thing, which I noticed on the warm-up problem, some of you guys are struggling with that. This is just algebra, so we're just going to play around with this. So we're going to get 3x plus 6 equals 2/3. And now I can combine these two like terms. So 3x plus 2x is 5x. And then 6 minus 1 is 5. Now I'd like to get rid of this 2/3 thing here. So let's multiply both sides by 2. I'll show that in, let's say, blue. I'm going to multiply this side by 3, and I'm going to multiply this side also by 3. And the reason I'm doing that is that 3 there will cancel with this 3 here. So that gives me 9x plus 18 using the distributive property. And then I'm going to get 2 times 5x plus 5 over here. So 9x plus 18 equals 10x plus 10 using the distributive property. All right, now we're getting close. I'm going to minus 9x on both sides. I'm going to show my work over here. So when I subtract 9x from 10x, I'm going to get 1x, or just x. And then I'm going to subtract 10 to this side. That's going to give me 8. So x is equal to 8. Now, the good news is that this problem works out very easily. I shouldn't say easily, very nicely, because we got a nice answer of 8 and not some decimal. But you can see it required a lot of effort and a lot of work. Now, I claim there's actually an easier way to do this problem. Would anyone be interested in seeing the easier way to do this particular problem?
Yes.
Yes. Okay. So let me go back here for a second. Let me go back to this slide here. And I'm going to go back to this first problem that I asked you guys about. I'm going to erase all this stuff. Remember a few seconds ago, I said this segment right here was 2/3 of the whole thing, right? This piece right here turned out to be 20 in this example, right? Well, if the whole thing is 30, what's this distance here have to be? Oh, wow. She's done already. Okay. What's that distance there going to be? If the whole thing's 30 and this is 20, what's GC?
10.
It is 10. Thank you, Nolan. I think that was Nolan. Thank you, sir. Do you notice anything? Well, it turns out that if this is 2/3, this has to be 1/3. And by the way, what do you notice? That means that this always has to be twice that. So a shortcut that we could do here is instead of writing this big long equation here, which I did, and that's completely fine, the other thing that I could have done is I could have just said that 3x plus 6 is equal to 2 times 2x minus 1. Because I claim that this distance here is double this distance there. In fact, let's just go ahead and work this out, and you guys tell me which one you think is easier. So I'm going to minus 3x over there, that'd be x. I'm going to add 2 over there, that's 8. X is equal to 8. Okay, I'll move on. So, oh, by the way, x is 8. I haven't finished this question, have I? This question asked me to find BF too, right? Well, what is BF? BF is this entire distance right here, correct?
Yeah.
BF is this length right here, all of this stuff added together. It's 3x plus 6 plus 2x minus 1, which is the same thing as 5x minus or plus 5, right? What's x? Well, it's 8. So if I plug 8 into that, that's going to give me 45. BF is 45. The length of that segment, BF, is 45. So let me say this again, and listen carefully, because you're going to maybe be asked a question in the near future. X is 8. BF is 45. Oh, we have a poll question. Would you please answer the poll? It will be popping up right now. I am not sure why I'm wearing this mask. I am in this big room by myself and I'm wearing a mask. I guess that's good. Okay, good. It looks like most of you know the answer to that question, so that's great. It looks like about 2/3 of you have voted, so I guess that's better than nothing. Okay, I'm going to end the poll now. Guys, I'm trying to keep track of who's actually paying attention and who's not, so that's why I'm doing these polls. So let's go ahead and continue on. This property here, this is the comparison property, and it basically gives us a format, if you will, for like if I said that, 7 is greater than 3, right? You guys would agree that 7 is greater than 3. So how could I write that as an equation? So the way we could write that is we could say that 7 is equal to 3 plus some amount C that's greater than 0. Now, I don't want to spend a lot of time on this property, but this is just, this equation here is equivalent, if you will, to this inequality. And we use it a lot when we're trying to show that something's bigger than something else. So now we're going to get into section, this is 5.6. And so these are about triangle exterior angles and ordering sides and angles of a triangle. So here's what this one says. And it's going to use this property here, right? So if I know that 7 is greater than or equal to 3, then I know that 7 is equal to 3 plus some amount. So this theorem says the following. It says that the exterior angle 1 has to be greater than angle 2 in measure, and it also has to be greater than measure of angle 3. And that should kind of make sense, because if you recall, the triangle exterior angle theorem says that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. That's all the way back, I believe, from chapter 2. So if angle 1, this angle here, if it's equal to these two guys added together, then clearly angle 1 has to be bigger than just 2. And clearly, angle 1 has to be bigger than just 3. Now, I do think that this particular theorem is intuitive. I think that anybody could look at that and say, yeah, that makes sense. If this was whatever this, if this is 50 degrees and this is 40 degrees here, this angle 1 has to be bigger than 50 and 40. In fact, it turns out to be 90. Okay, so let's look at this equation or this problem, and it says use the figure at the right. Why is angle 2 greater than angle 3? So we're talking about this angle here and this angle here. So I'm just going to go ahead and work this one out. Hopefully you guys can see that okay. But I hope that you would all agree that angle 1 is an exterior angle to this triangle up here. So this triangle right here is triangle ABD. Hopefully you agree that angle 1 is an exterior angle to that one. So based on that, I can say that angle 1 has to be greater than the measure of angle 3. That has to be true. And the reason it has to be true is because of this theorem right here. This theorem says that the measure of angle 1 has to be greater than either of the two remote interior angles. And that's exactly what angle 3 is. So angle 1, which is a remote interior angle to angle 3, angle 1 has to be greater than angle 3. Oh, by the way, what's true about angle 1? Let me put measure here to be more specific. Oops, I guess I already did there. What's true about the measure of angle 1 and the measure of angle 2? Well, they have to be equal. And the reason that they have to be equal is because these two sides are congruent. So this is by the isosceles triangle theorem, and that's something we talked about a couple of weeks ago. And by the way, if the measure of angle 1 is equal to the measure of angle 2, then that means the measure of angle 2 could be substituted in for the measure of angle 1, which means that the measure of angle 2 is greater than the measure of angle 3. And that is exactly the result that we wanted to get. So let me explain what was going on there. There was a couple of things. Now, obviously, we just talked about this corollary to the triangle exterior angle theorem. So this was the corollary to the triangle exterior angle theorem. And then we used the fact that angle 1 and angle 2 had to be equal in measure because of isosceles triangle theorem. And then we can put these two things together to conclude that the measure of angle 2 is greater than the measure of angle 3. So why do they have to be greater? I've just provided the argument. Okay, so the next two theorems I think are also very intuitive. So here's the deal, and let me just explain this. It says if two sides of a triangle are not congruent, then the larger angle is opposite the larger side. So here's what I'm telling you. If you see this side right here, let's say this side is 12. I don't know what it is, but let's say that it's 12. And let's say that this side over here, this blue side, in fact, let me do it blue. This blue side over here is, let's say it's 8. Okay. Now, hopefully you can see that angle Z is across from 8. And hopefully you can see that angle Y is across from 12. So here's what this theorem is saying, theorem 8.10. It says since 12 is bigger than 8, then Y is bigger than Z. That's what it says. That kind of makes sense, don't you think? The opposite side's longer than this opposite side, so this angle has to be greater than that angle. So this is theorem 10 or 5.10. All right, let's look at an example of this here. It says which angle is larger? Angle A, that's this angle right here. I'll put a little star on it. That's angle A. And angle ABD, that's this angle right here. Well, let's see here. The side opposite angle A is 5 units long. The side opposite angle B is 6 units long. So which one's larger? Angle ABD is larger. And I would say because 6 is greater than 5. All right, let's look at part B. Which angle is larger? Let's do this in blue. Angle C, that's this angle right here, or angle CBD? Angle CBD, that's this angle right here. All right, well, let's look. Across from angle CBD, well, that's 8. Across from angle C, that's 5. So guess which angle has to be larger? Well, of course, angle CBD. Angle CBD is across from the longer side. And I'm going to say because 8 is greater than 5. So now I'm going to ask you to maybe try to figure out this last one. Which angle is larger? Angle A or angle C? And I'm going to give you just a second, and I want you to type your answer in the chat, not in the poll, but in the chat. I want you to type the answer. Which angle is larger, angle A or angle C? I'm going to erase all of this stuff. Okay, good. Interesting. Oh, wow. I've got a couple you said that said it's equal.
Wow.
Interesting. Okay. So this is one of those moments where as a teacher, it's like, this is like what we call a teachable moment. And so far, I've gotten some really interesting responses. Okay, so I've got 1, 2, 3 people said angle C, 4 said angle C, 2 of them said equal. Okay, I'm going to stop you there, and I'm going to tell you, unfortunately, the correct answer is, oops, let me put my marker back on. It's angle A. Nobody got it right. So, yeah, I changed my mind too. Yeah, good. So why is that? Mr. Allen, that doesn't seem right. That doesn't seem right. So let's go back and look at this theorem again. Now, this is one of the things where, as a student of math myself, these theorems are very important. This theorem says the following: if two sides of a triangle are not congruent. So when I asked about this question down here, you have to look at the big triangle now. The first two questions, I looked at each of the smaller triangles. Look at the big triangle now. Forget that this here in the middle is even there. Can you see, in fact, let me do it in purple. Can you see that angle A is across from the 8? And can you see that angle C is across from the 6? So angle A is the bigger angle, and I'm going to write because 8 is greater than 6. Now, I'm going to stop here real quick and see if you guys have a question on that. We're running low on time. We've only got about 6 minutes left. Does that make sense? What's that?
He said Coach Stu missed that one.
Okay. That's all right. Look, that's why I put this on here. And I'm not trying to be a trickster or anything, but I think that this is a question that once you see the answer, it makes perfect sense. It's not you. Sometimes you can actually, the math can get in the way if you don't think carefully about it. So the issue with this last problem is the fact that we have multiple triangles here. There are 3 triangles. When I did this first problem here, I was only looking at this the small triangle on the left. When I did the second problem, I was only looking at the triangle on the right. But then when I came to this third question, I had to look at the big triangle. All right, let's go ahead and finish this out. Here's the last theorem. I think this is the last theorem that we're going to look at. And this is just the converse of the last problem, of the last theorem. So here's what it says. If angle A is, let's say it's 100 degrees, and angle B is, let's just say, I don't know, 30 degrees, guess what we can conclude about the opposite sides? Well, if this angle is 100 and this angle is 30, then the length of this side here, BC, is going to be greater than this side, AC. Someone just typed in 70. I'm not sure what that's about. Okay. So again, here's what it says. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So here's what I'm going to do. I'm going to shut up now. I'd like you to answer this question, and we'll kind of probably wrap it up pretty much after that. I can't remember if there's one more theorem or not, but I think this is basically it. So here's our triangle ABC. I want you to tell me the angles. In fact, just do it on your own. You don't have to type anything in. I want you to give me the angles in order from least to greatest. Smallest angle first, then the middle angle, and then the third angle. Least to greatest. Okay. Now, I would love it if someone would just unmute themselves and tell me what the answers are. That'd be fantastic.
I would say CBA.
Okay,
Angles.
angle C, angle, did you say B?
Yeah.
And then angle A?
Yeah.
Okay. Let's see here. Anybody want to agree with him or disagree with him?
BAC.
Okay, so someone else says angle B, angle A, and then angle C. Any other takers? Okay, so let's go ahead and answer this so we're not wasting too much time. Would you guys all agree that that's the shortest length? If that's the shortest length, it has to be across from the smallest angle. So that means that this is going to be the correct answer. Angle C is across from the longest length, so it has to be the largest angle in that triangle. So there's the correct answer. Let's see if we've got anything else here. Oh, we have one more, but I've got one more poll question for you. In fact, let me go back to this real quick here. We said that angle B was the smallest, angle A was in the middle, and angle C was the biggest, right? All right, here's your poll question. Oops, hit the wrong thing. Try again. Okay, there's your poll question. And while you guys are answering that very simple poll question, I'm just going to hit this last theorem, and then I'll give you the exit slip that you'll need to submit. In fact, let me just explain to you this last theorem. Let's say that this is 3, this is 4, and this is 5. This is what this theorem says. This theorem is called the triangle inequality theorem, and it says the following. The sums of the length of any two sides of a triangle have to be greater than the third side. So would you guys agree that 3 plus 4 is greater than 5? Well, yes, that's clearly true. This always has to be true. For example, you could not have a triangle, with the 3 sides, 2, 3, and let's say 100. And the reason you can't have that is because, think about it. Let's say I draw a length that's 100. There's 100 length. And then I'm going to draw this length right here. That's 2. There's 2. And I'm going to draw this length right here. Let's say that's 3. There's 3. Can you put those 3 segment lengths together to make a triangle? That 2 and that 3, they're never going to reach the other end. It's not possible. So that's what's encapsulated in this theorem. And the theorem is simple. It just says you should be able to add any 2 sides of a triangle, and it should be longer than the third side. All right, guys, so we're at time here. I want to finish this off. I'm sorry we're running a little bit long here, but I do want to talk about this. It says, suppose the length of the 2 sides of a triangle are known, 5 and 8. Discuss the possible lengths of the third side. Well, 5 plus 8 is equal to 13. So here's my question. Could this third side have a length of, let's say, 18? Well, no, it can't, because 5 plus 8 is not greater. So this is not possible. In fact, it has to be somewhere between 13. And can anyone guess what the lower length has to be greater than? Adding these together gave me 13. So I know it has to be less than 13. Does anybody know what the lower end has to be, the lower amount?
Would you subtract them?
Yes. And what would that answer be?
3.
Correct. I'm telling you that if these 2 numbers and a third number are going to make a triangle, it has to be between 3 and 13. So, for example, could we have another side that measures 9? Sure, because 9 is between 3 and 13. Could we have one that's 15?
No.
Nope, can't do that, because 5 plus 8 is not more than 15. Can we have a third side that is 1?
No.
Oh, is 1 between 3 and 13? Nope, not
Which
possible.
lower?
And the way you can think about that is this. Let's say that this is true, that 1 could be a third side. Well, what's 1 plus 5? Well, that's 6. Is 6 greater than 8? Nope.
No.
That's why this is not allowed. So this theorem, I think, is pretty intuitive. Basically, any 2 sides has to be greater than the third side. So I'm going to go ahead and wrap it up there. I'm going to send you the exit ticket, and then you guys will be free to go. I am going to stick around if you have questions. Give me 1 second here. I've got to get this link to you. I'm going to stick around after this presentation, and then you guys can ask me questions if you have them. Remember, we have a final exam next week. You have a homework assignment due at the end of this week. Where is it at? Oh, there it is. Okay, sorry. Okay, send. Okay, in the chat, I have a link to the exit ticket. I would really appreciate it if you would do it. Just real quick, easy questions, I think, and then you are free to go for the day. Please complete the exit ticket before you leave. I'm going to stay on here. If you have any questions about the last problem or any of the problems, I will be glad to answer those questions. I'm going to stop recording now. Stop.